When we have inequalities that involve absolute values, remember absolute values being the symbols that look like that, these are hidden compound inequalities. If we have a less than or a less than or equal to, we're going to think of this as a less than statement, a less than statement. If it's less, it's a hidden and. And if it's a greater or greater than or equal to, we have a hidden greater statement. And you'll see what I mean in just a second. How do these one equations, even though there's one inequality sign, become a compound inequality? Well, because remember with absolute values, we have two cases with an absolute value. And now, our two cases, we remember we have one, the obvious case. The case that would happen if we took it as is. And if you remember with an absolute value, we would also have a case that would be, we would call it the sign change, where we would take what's in the absolute value, keep it the same, equals, and change the sign. Well, in an inequality, we have the double sign change case. We change the inequality sign, and we change the positive or negative sign. So let's look at an example. If we have the absolute value of n minus 8 is less than or equal to 2, when we set up our two cases, we have the obvious, n minus 8 is less than or equal to 2. We have the double sign change, n minus 8 is greater than or equal to negative 2. And we look, absolute value of n minus 8 is less than, and this is an and statement. So let's go about solving. Plus 8, n is less than or equal to 10, plus 8, n is greater than or equal to 6. When I go in set builder, I have the set of n such that I rearrange from least to greatest. 6 is less than or equal to n is less than or equal to 10. On the number line, I take my values. I have a closed dot on 6, a closed dot on 10, and I connect the dots in between because it's an and statement, Remember, and statement because less than. We have our obvious case where we just take it out of the absolute value and do it as is. We have our double sign change. Over here, and we're good to go. Now, let's look. If we have the absolute value of 2c minus 5 is less than negative 3. Think about it. What does an absolute value yield? An absolute value always yields a positive. So can we have a positive less than a negative? No solution. We'd have a number line that's blank. So if an absolute value is less than a negative, we're going to have no solution. But most times, absolute value less than and 2, we have a hidden and statement. In the event that we have the absolute value of 2k plus 1 is greater than 7, the absolute value of 2k plus 1 is greater than 7. We take our obvious case, so 2k plus 1 is greater than 7. We take our double sign change, so 2k plus 1 is less than negative 7. And we have the absolute value of 2k plus 1 is greater than, or, there we go. We have an or statement. So now we solve. So 2k is greater than 6, which means that k is greater than 3. Minus 1, 2k less than negative 8, k less than negative 4. In set builder notation, we have the set of k such that I'm going to say k is less than negative 4 or k is greater than 3. When we go to the number line, I have 0, I have negative 4, less than, going out, I have 3, greater than. So there's my solution to the absolute value of 2k plus 1 is greater than 7. We have an or statement. 2k plus 1 is greater than 7. 2k, that's what this says over here. 2k plus 1 is less than negative 7. we solve, we get k is less than -4 or k is greater than 3. And for an or statement, we have two lines that protrude out. Now, if we have the absolute value of r minus 6 is greater than or equal to -5, think about it. An absolute value always yields a positive. So if is a positive number greater than or equal to a negative number, you betcha. So here we're going to have all real numbers. So we have the set of r such that r is a real number, also known as r such that r is an element of the set of real numbers. And when we graph this on a number line, we graph the whole line. At our practice problems today, we have page 765, number 9 through 27, multiples of 3. Number 9 says the absolute value of r plus 1 is less than or equal to 2. So I'm going to take r plus 1 is less than or equal to 2. There's my obvious case. R plus 1 is greater than or equal to -2. There's my double sign change case. We have less than or equal to. This is an and statement. And I would solve from there. Have fun. Rewatch if you have any questions about absolute value inequalities.